Let's continue on the topic of acceleration. Let's go over these conceptual questions. So multiple choice, I think the questions you like the most. Sort of try your luck. And neglecting air resistance, a ball that in free fall will have basically a free fall. Do you see that very often? You drop something that is a free fall. And of course, speed will increase. And now it's the acceleration, okay? And the acceleration increase or decrease. And the idea is the acceleration is a constant. It's going downwards. So acceleration is going all the way to, it's called a g. And that acceleration is 9.8. That's a very well-known number. If you take any physics class, you will see that the downward acceleration is 9.8 meters per second squared, which means each second velocity will increase by 9.8 meters per second. So therefore, 9.8 meters per second squared. So with constant rate, but that rate is constant. Therefore, the choice is D. So increased speed and constant acceleration. That acceleration is actually called G. All right. So now number 2, neglecting air resistance. A ball rolling down the rope of the slope of a steep hill will have, and even though that way, rolling down a constant slope, rolling down like this, and basically it gets just partially the gravity, but that partial acceleration of gravity is still a constant. Of course, the steeper the hill, the stronger the acceleration. But that acceleration is a constant. It will increase speed. So increase speed, constant acceleration. So, but it's just smaller than g. So acceleration, some acceleration, but in somewhat less than g. The highest acceleration is just a free fall by g. All right. Again, just to emphasize the concept. Again, neglecting air resistance, a ball throw straight up, okay, will come to momentarily stop at the top and then turn back down. What will be acceleration at that moment? So it's like boom, go up. What's the acceleration over there? So the acceleration is there all the time. So acceleration is always in this direction. The argument is that you go up, the acceleration against your speed, so your speed reduces. And one at the top, and then acceleration is still there and go downwards. So at this part, and still acceleration. When it stops and the acceleration is there, and actually it is the acceleration that made it stop, and then made it accelerating, speeding upward. So the story here is, if you have something tossed up, and the acceleration against it, and so it's reduced to 0. And then when it turns, it's accelerating increased speed, but the other direction. So therefore, the answer is this. Let's solve a couple of problems. What is the acceleration of a car that moves from a rest to 20 meters per second in 9 seconds? So this is simply just apply the definition. So acceleration is actually the velocity change. You call it, whenever you denote some change, you usually always use a delta, and divided by the delta change in time. So whenever you calculate any change, you have the final and minus initial, or the later value subtract or minus the earlier value. So that I will call it initial and final, always like that. And of course later time, okay, and minus initial time. But in this case, this implied that the later velocity is 20. The initial velocity is 0. Which word says 0? Because it's at rest. So minus 0. Let's just put there to hold the place so that you know where it came from. Okay, final time is 9 seconds. Initial, of course, start from 0, the stopwatch. So it's now math is very small part of this. 20 divided by 9, you will get 2.2. Okay, 2.2 meter per second squared. Question number 2. How long will it be required for a car to go from speed of this 20 meter per second to a speed of 25 meter per second? This time is speeding up really from 25. What's the change? Change is 5 meter per second. Okay, if the acceleration will be this. So this is the same idea, but apply this formula the other way. So A is change in velocity and divided by time. Now we know what's the change. Okay, and we want to know how long time does it take to make such a change. So therefore we solve for t in this formula. T, okay, now we need to apply a little bit of math. Is equal to delta v divided by a. So delta v is change in velocity. Is now you need to do v final. Okay, and if you are so good, you don't really need to write down this, but since we are learning, I just write down v initial divided by a, which is that. So then what we have here is 25, that's final velocity, that's acceleration, minus 20. So 25 minus 20, you'll get 5. And then divide by 3, which is the acceleration. Now we keep going, and then it's 5 divided by 3. You get 1.6, 1.66 bar, which means you can't. It's not divisible. But then, and what's the units? We'll ask for time. Should be time units. Should be in seconds. So, which means you're accelerating with this acceleration. It will take 1.66 seconds to increase the speed from 20 meter per second to 25 meter per second with this acceleration, which means 3.0 meter per second squared. So it takes 1.66 seconds to do such a acceleration. Okay, number 3. If an object has just released from your hands, how far vertically will travel down in 1 second, 2 seconds, 3 seconds. Now this is one very straightforward. So now you should know that when accelerated motion, the distance as a function of time is actually half a and time squared, because the accelerated, okay, with square, which means getting faster and faster. So now in this case, the time, the acceleration is the special. It's g. G is actually 9.8. Actually, acceleration is actually g. All right. So acceleration is g, and then g is 9.8. I just derived this. In solving problem or homeworks, you just simply write down this part, and you will get a full credit. T squared. So now you have a formula. The rest is simply, so now if you have 1 second, then it's interesting. So it's interesting to know if you drop something, wait 1 second where it is down from your hand. So that's what you're supposed to calculate. 1 second, the object will drop this much. So what I'm writing here. Okay, and what is 1 squared? So t is 1 second, 1 squared. 1 squared is 1/2 is 4.6. Divided by 9.8 divided by 2 is 4.9 meters. Almost 5 meters. So if you let go of a tennis ball or basketball, neglecting air resistance, it will drop 5 meters, 4.9 meters per second. So now the rest is just calculate. Just appreciate this formula. 2, and then of course, then half 9.8. Okay, and then you will get 2 squared. Okay, you see, it will get 2 squared is 4. 4 times 1 to 2. That 2 times 4.8, 9.8. You get a 19. You get 19.6 meters. Okay, I leave the 3 seconds in actually D3. Okay, and you will go over. Actually, you get, just ignore the calculation. You get 41 meters. It's getting bigger and bigger distance, further, faster, faster. And that's this nature. Remember this formula. This goes accelerated motion, but this time downward. Well, the last question is a little bit puzzling, but once I resolved it and we explained it, it will become simple. If an object tows straight up, okay, with a speed of 5 meters per second, that's real, kind of a realistic situation. You would toss a ball, or kick a soccer ball to the air. Okay, how long will it take to reach the top? So, how do you start thinking about it? What's the characteristics at the top? Okay, at top, the ball momentarily stops. Okay, the velocity is 0. So from 5 meters per second goes to 0. So you have a change in velocity. We'll just leave the hands. It's 5 meters per second. It's going kind of fast. But then once you reach the top, the velocity is 0. So what make it reduce to 0 then? That's the acceleration. Okay, the acceleration is g. The g is going downwards. The velocity is going upward. So the acceleration make it the velocity decrease. So the velocity change is, so final velocity is actually 0. The initial velocity and actually 5. So 5 meters per second. So the change is a -5. Agree? Because it's -5. Because it's going down. So that's positive. And then becomes 0. So that's initially 5. Okay? And then it becomes 0 on the top. So the change is -5 meters per second. So if you say the positive is different. And what is the acceleration then? Acceleration, so if you say this is the positive direction, and the acceleration is actually down. Okay, g is 9.8, but in this case, negative. Okay, so this is negative acceleration. So the acceleration is negative. So acceleration here is g. Okay, and is equals to g in this case is -1.8. So -9.8. But whenever people ask you what is the value of acceleration, you simply say, okay, 9.8 meter per second squared. But actually, that's the absolute value of it. Whether it's positive or negative, depending on which direction you choose as positive. So in this case, we choose up direction as positive, therefore downward is going downwards. So acceleration is always going towards the earth. So therefore the change, how long does it take? So change to 0. So therefore the time it takes, once again you use the same formula. So the time is equal to, so delta V, okay, and divided by the acceleration, okay, by the acceleration, which is now is a g, and then you will have -5, which is the change in velocity, which is reduced to 0, and -g, which is a downward acceleration. Actually, it is downward acceleration that made a negative acceleration change, reduce the speed. So then if you do the division, you will get like a half a second, 0.51 seconds. Right, so 0.51 seconds. So this question is also interesting because if you toast something 5 meters per second, you reach the top in half a second, so 5.1. So this is not the problem. And next topic would be Newton's law. We will introduce forces and things.